we're doing. So let's do ionic versus polar versus nonpolar. So and what we've seen is that CCl4, carbon tetrachloride, is nonpolar. We've seen that NH3 and H2O are polar. We've seen that lithium nitrate is ionic. We also saw that HCl was polar. Okay? And so you're starting to see that so things with hydrogen in them tend to be polar. There are exceptions. CH4 is nonpolar, but that's because there are 4 hydrogens arranged symmetrically around carbon. Get on the page there. There we go. So the dipole that exists between hydrogen and carbon cancels out because of all the equal dipoles around it. So here's a nice set of examples. NH4Cl is ionic because it's got ammonium and chloride. NH2Cl is polar because it's got dipoles that don't cancel. I'm trying to think, I don't think I can come up with a non-polar example with nitrogen. What about HNO3? Good question. Well, so we won't put it in a category yet. Oop, that's not what it looks like. If we draw HNO3, and this is why it's so important to be able to do Lewis structures. We would see that the best Lewis structure looks like this, with a minus and a plus formal charge. These formal charges do not mean it's ionic, by the way. This has no overall charge, so this is a covalent molecule. It's not an ion. And then what we would say, if we draw dipoles on this, well, again, the process, so we draw the best Lewis structure. We then draw its shape. We can see that this nitrogen has 1, 2, 3 electron groups. That means it will be trigonal planar. Let me see where I have enough room here. Well, we can talk about the whole resonance structure thing in a minute. Now, this oxygen right here has 1, 2, 3, 4 electron groups. That means it will be tetrahedral, and that means I should draw an H at an angle there with 2 spots, 2 pairs of electrons over there. And we keep going. I hope this just had a momentary lapse there. So, all right, now this is the best Lewis structure drawn in its shape. And that's always where you want to draw your dipoles. My dipoles look like this. Though I'm not done. If these were the only dipoles, yes, this would be nonpolar because you can see all 3 of these dipoles point in equal and opposite directions. But then we add in this dipole. And as long as there's one dipole that doesn't cancel, we would call this molecule polar. And when we get to intermolecular forces, this OH bond allows it to do hydrogen bonding. Which again, we'll talk about on December 5th, actually, when we go over the next homework in our next class meeting. Hopefully that answers your question. So we'll put HNO3 under polar. Here's my list. Any other questions?
Hi, Professor. Would two dipoles that are hydrogen cancel out with two other dipoles that are facing in the opposite direction?
They would not.
They would not.
Yeah, so I don't know if you're talking about maybe CH2Cl2. But
yes, anything with a H2 and then two other atoms.
yeah, so basically now you've got carbon bonded to the two H's and the two Cl's. If we drew that eventually in its shape, and again, this is like maybe your goal is to get to the point where you can think about this process, but until that point, always draw the best Lewis structure, draw it in its shape, draw dipole arrows. But when you do this, these four arrows clearly do not point in equal and opposite directions, which is what you need to have a nonpolar molecule. So this will be polar. And I know it's a lot. And that's why, like, again, hopefully what you find is that as much as it is, if you keep up your work, it will be at a reasonable pace. And that's, in fact, with the holidays and everything, why we are not, like, why we did our last lecture outline that was due last night. Why we only have this homework and one more. Because, again, I know it's a lot of work, and I know you're working hard. But at least we're going to try not to pack anything else in at the end. So there is that.
Professor, so
Yeah,
just to clarify,
of course.
two going in and two going out do not cancel each other out?
That's right.
So they all have to be going in one direction?
They all have to be going in one direction.
Thank you.
Yeah, good question. So that's a bunch of examples. And what I'll do is I'll leave it there.